In this video, we're going to be looking at dividing products of powers. Before we get onto that, there is an important mathematical idea you need to be comfortable with. So here's a quick question on that. It should take you no more than 10 seconds. Pause the video and have a go. Without using a calculator or doing any calculations, you should have found that this is simply going to give us 17 over 23. There's absolutely no need to work out what this numerator is or this denominator is. I can see that 17 is a factor of the numerator and the denominator. So I can simplify before even working out this product. Similarly, I can see that 23 is a factor of the numerator and the denominator. So I can simplify like this. And that just leaves me with 17 over 23. If you're not sure about what's going on here, you need to go back to topic N to F. It will help you hugely, not just with what we're about to see in this video, but with loads of other areas in maths as well. This is a big idea that is really well worth understanding properly. Here are the examples. In example A, we've got a cubed b to the power of 7 divided by a squared b cubed. Don't forget there are invisible multiplication signs here and here. So what we're really doing is dividing a product by another product. Now, before I explain how to do it, I'll just show you what we actually do. To work out the missing index for the a, we simply realize that we are doing a cubed divided by a squared. And we know from the previous video, when we are dividing powers with the same base, we can simply subtract these indices. So 3 minus 2 gives us 1. Similarly, we can do the same thing with the b. 7 minus 3 gives us 4. So a cubed b to the power of 7 divided by a squared b cubed is simply a to the power of 1 b to the power of 4, which we could write more simply as a b to the power of 4. Remember, if we've got something to the power of 1, we don't normally bother writing that 1 in the index. Now, why does this work? Well, I could write this division as a cubed b to the power of 7 over a squared b cubed. Now, what I can do is split this into a product of two fractions. I'm saying that this fraction is equivalent to a cubed over a squared multiplied by b to the power of 7 over b cubed. Hopefully this makes sense. If you think back to multiplying fractions, hopefully you remember that multiplying fractions is easy. You simply multiply the numerators and you multiply the denominators. And you can see here, if you multiply these numerators, you get this one here. And if you multiply these denominators, you get this one here. So this fraction is equivalent to a cubed over a squared multiplied by b to the power of 7 over b cubed. Now, why is that helpful? Well, we know how to simplify these. What we have here is a power divided by a power where those have the same base. Here, we've got a power divided by a power where they've got the same base. And from the previous video, we should be able to do that. A cubed over a squared is simply going to be a to the power of 1. All I did there was 3 minus 2. And then I need to multiply that by b to the power of 7 divided by b to the power of 3, which is b to the power of 4. What did I do there? Simply 7 minus 3. And that's our answer. Now, in algebra, we can leave out the multiplication sign. So that gives us a to the power of 1, b to the power of 4, which is exactly what we filled in here. Of course, as I mentioned, normally when we have something to the power of 1, we just leave out that index. So a to the power of 1, b to the power of 4 would more normally be written as ab to the power of 4. Now, I showed you all of this to help you understand what is going on. Normally, you don't need to show all of this working every time you do a question like this. Let's move on to B. We've got a cubed b to the power of 4 divided by a to the power of 7 b cubed. Just like before, I've got a product of powers divided by a product of powers. And we've got some of the same bases. So what I can do is subtract indices just like before. A cubed divided by a to the power of 7 is going to be a to the power of 3 minus 7, which is negative 4. B to the power of 4 divided by b to the power of 3 is going to be b to the power of 4 minus 3, which is 1. So we've filled in the missing indices. Now, normally, again, we wouldn't necessarily write b to the power of 1. We would just write that as b. So a to the negative 4 b to the power of 1 could be written more simply as a to the negative 4 b, or b over a to the power of 4. This stuff here on the right is just for your information. We didn't have to write this down as part of answering the question. Moving on to C, I've got a cubed b to the power of a half divided by a to the negative 2. Well, for a, the index is going to be 3 minus negative 2, which is 5. The index here is simply going to be a half. Let's just see a couple of ways of looking at this question. I can write the division as a fraction, and what I can put in the denominator, if you like, is a b to the power of 0, because b to the power of 0 is simply going to be 1. So all I've done is multiply this by 1, which doesn't change the denominator. And then, like I demonstrated earlier in the video, we can split this up into a product of two fractions. And from here, hopefully you can see why we can do 3 minus negative 2 to get the 5, and a half minus 0 to get the half here. Now, because it's a really good idea to try recalling ideas that you've met before, I'm going to go through this again in a different way. I've got a cubed b to the half divided by a to the power of negative 2. Now, I know that this is simply 1 over a squared. Now, we know how to divide by a fraction. We simply multiply by its reciprocal. So what we've got here is a cubed b to the power of a half multiplied by the reciprocal of 1 over a squared, which is simply a squared. You flip this fraction over, so you get a squared over 1, or just a squared. And hopefully you can see that this will simplify to a to the power of 5 b to the power of a half, which is exactly what we've got up here. Let's move on to question D. Pause the video and work this one out for yourself. Here's what you should have got. We've got a multiplied by b to the power of a half over a multiplied by b cubed multiplied by c. So we've got products, and we've got some of the same bases in these powers. Let's put in the invisible numbers. We've got a to the power of 1 here, and a to the power of 1 here. We've got a c to the power of 1 here, and we can think of a c to the power of 0 in the numerator. Now, for the indices, we simply need to subtract. 1 minus 1 gives us 0, so we have a to the power of 0. A half minus 3 is the same as a half minus 6 over 2, so that's negative 5 over 2. And for C's index, we've got 0 minus 1, which is negative 1. So we have filled in these missing indices. Now, if we were writing out this quantity normally, we wouldn't bother writing a to the power of 0. A to the power of 0 is just 1, so we would leave it out and write b to the negative 5 over 2 multiplied by c to the negative 1. Or we could write it as 1 over b to the power of 5 over 2 c. Now, just like these earlier bits on the right hand side, this is not necessary to answer the question, to fill in these missing indices. I've just shown you this here for your information.